Hello, I'm Anna Mackay and this video is on domain and range, and it's the second one in its pair. Working on some slightly harder concepts here. So to fully describe a function, we need both a rule and a domain, where a rule is an equation that you're usually used to seeing, and then a domain refers to the x values that it can take. So if we had to sketch that graph, so y equals x squared, I'm going to do this very quickly. So you usually have your Cartesian plane, x and y axis. Now, just a little point there, a sketch can be very rough. If it said draw, we would want a little bit more accuracy, a proper scale, that sort of thing. A sketch, as I said, can be rough. Now, this is how my brain works. I think, okay, well, what does x squared look like? It's a parabola that goes through the origin like that. But then because we only want x is greater than or equal to 0, that means we don't want any negative x values, so we just want that part. So you would draw just like this, arrow on the end, and it's always good to label what you've drawn there. So that's y equals x squared. So if a domain is not specified, we use the natural domain, which is the largest part of the real numbers for which f of x is defined. So what that means is you use the default, every possible value you could use if nothing's defined. Some examples of the domains are shown in the table opposite. Very handy to have this written down. So x squared can have all values of x. The square root of x, have a think. What happens when that's negative? It becomes an imaginary number. So for the real values, the square root must be greater than or equal to 0. It's okay to be 0. Fractions here, 1 divided by x. What do we know about the denominators there? That they can't be 0. Or we have an error, it's undefined, you can't have 1 divided by 0. And this equation, well, function here, 1 divided by the square root of x, that the square root component must be greater than or equal to 0. However, this time around we can't have 0 because it's in the denominator part. Okay, so having a look here, similar to the one we did before, that y equals x squared, this is the domain in this case because we haven't defined anything else, so we can have all values of x. Moving on to we're going to go through each of the three in the table there. Now, those that are going to have me for a couple of years of teaching, a technique that I talk about is create a visual. So as often as possible, get your graphics calculator out, type it into graph, and to see what it looks like. So here, if we've got the square root of x, start with a standard view window of 10, 10, negative 10 to 10, and graph it. You're probably not going to be able to see that neatly due to computers. And have a look. So have a look at what x values that can take, the domain there. And so then that will help you with so many questions. So you'll hear me say create a visual very often. And that's what that looks like. The next one, 1 divided by x, what does that look like? Start to become familiar with what that looks like. You could instantly do y equals x, or you could probably instantly do y equals x squared. Start to become familiar with these other ones. 1 divided by x looks like that. And you can see it's all values of x but not equal to 0. And that's what that looks like there. We have an asymptote at x equals 0. And then 1 divided by the square root of x, what does that look like? Well, that's all values of x but greater than 0. So it has an asymptote here as well, but there's nothing over this side of the graph. All right, some examples, domain and range. We're going to go through all three. The first one, f of x is defined when that the square root of x take 5, what has to happen with a square root? It has to be greater than or equal to 0. So that means that x take 5 has to be greater than or equal to 0. Now remember, all the neat setting out comes afterwards. So just that section. And now you use your algebra skills to rearrange. You're going to essentially add 5 to both sides, and you'll end up with x is greater than or equal to 5. So they're all the values of x that we need to have. And you can use that then in your domain, that x has to be greater than or equal to 5 in your set notation. So to be able to define a range, you have to often solve an equation before you can define that. Oops. Okay, and there's the graph of that. So all values for x greater than 5 or equal to 5. And the range, the y values, we cannot have a negative square root. And again, if you have drawn a graph of this on your calculator, it'll be really easy to see what y values. So it's all of the positive values of y. Can it be 0? Yes, it can, because that's the x-intercept there. The next one, 1 divided by x, take 5. That is defined when? So fractions are defined when the denominator is what? Not 0. So when x take 5 is not equal to 0. It can be negative, that's all right. Which value of x could you plug in there to make it 0? 5. So if x was 5, it's not defined, but it is defined everywhere else. Neatly written out like that. And the domain with so curly brackets each time, you do x, the straight line for it's the set, and we can just have x not equal to 5, close bracket. There we are. And draw a graph on your calculator. What about the range here, the values of y? Looks like all of them here in the negative region and then all of them here in the positive, except here. It's asymptotic behavior, so not at y equals 0. So the range is that notation. And the third one, 1 divided by the square root of x take 5. Now when is this defined? Not only does the denominator cannot be 0, but the square root must be, well, that has to be greater than or equal to 0, but as we learned from the previous table, it can't be 0. So this, x take 5, must be greater than 0 in this case. And what value of x will make that true? 5. So x has to be greater than 5. So domain, curly brackets, x is the set of for x greater than 5. There we are. And the range is all the values of y. So you look up the vertical axis and you can see there's nothing down here and it's all up here. Is it ever 0 though? No. There's no way we could ever get a 0, so it's always greater than 0. Okay, if you like this video, give it a thumbs up and subscribe to the channel. And the next video in this series is composite functions. Thank you.